Good evening, students. Next, we are going to explore about the electric actuators. Okay, so it is one of the final control element where you are going to use a electric signal as a actuator. Okay. Yeah, so first one is electric actuator. Okay, so the electric actuator, it is widely used in most of the control system. The best one is a motor. The motor works on the principle that when a current carrying conductor is placed in the magnetic field, it experiences a mechanical force. Okay, so if you see, we have a different type of motors like DC motor, AC motor, and stepper motor. Okay, so DC motor, we are going to give a DC supply. So when you give a DC supply, and accordingly, it is going to experience a mechanical force. Okay, and similarly you have a AC motor where you give a AC current as a supply, and accordingly it is going to convert that to a mechanical force. And last one is a stepper motor is going to it is an electromechanical device which converts a electrical pulses into a discrete mechanical motion which can move in the form of a steps. Okay, so in most of the industries, stepper motor is mainly used in many automation application. We have a three different type of stepper motor like permanent magnet, variable reluctance, and hybrid type. Coming to the stepper motor, it is used to produce a rotation through equal angle in the form of a step, for which a digital pulse is applied as an input. Okay, and if you take a variable reluctance motor, you will have the setup will be in this form of a rotor is made up of a soft steel, and it is cylindrical with four poles. When opposite pair of windings as a current switched, the magnetic field is produced, okay, from the stator to the nearest pole of rotor, and accordingly it is going to have a minimum reluctance. Okay, that is called variable reluctance. Here usually the step angle maintained is 7.5 to 15 degree. Coming to the permanent magnet motor, stepper motor, it has a two-phase four-pole coils on the opposite pair of poles are in series. Okay, current is supplied from a DC source, and rotor is a permanent magnet. The rotor rotates in 45-degree steps, and step angle is either 1.8, 7.5, 15, 30, and 34 or 90-degree respectively. Okay, and coming to the hybrid stepper motor, will be a combined feature of both a variable reluctance and a permanent magnet motor. Okay, so permanent magnet is enclosed in the iron caps that cut to have a teeth, and it motor has a N phase and M teeth on the rotor, and total number of steps per revolution will be N into M, and it can rotate at the step of zero point 0.9 or zero point 0.8 degree available. High accurate position can be achieved when you go for a hybrid stepper motor. And coming to the next one is a servo motor. Servo motor is a small device that has an output shaft. A shaft can be positioned to a specific angular position by sending a coded signal. As long as a coded signal exists on the input signal, the servo will maintain an angular position of the shaft. As a coded signal changes, the angular position of the shaft also changes. A servo motor is constructed out of the DC motors. Okay, and you have a DC servo motor which is of different type, DC servo motor and AC servo motor. So when you take a DC servo motor, when you take a DC servo motor, you can have a series, a shunt, and compound wound DC motor. And if you take a AC servo motor, you have an induction motor and synchronous AC motor. Okay, so the DC servo motor are controlled by a DC command signal applied directly to the coil. Whereas if you take a AC command signal is given to the coil. Okay, so here AC servo motor, it has a two-phase AC induction motor. There are two windings, one fixed or reference winding is supplied with a fixed voltage and frequency from a constant voltage source, and second winding is called as a control winding with a variable supply. The stator has a two distributed winding displayed 90 degree apart. One winding is a reference and it is connected to the constant voltage source. Another winding is a control phase and it's supplied with a variable voltage and it is displaced by 90 degree. Okay, thank you students.